Welcome back, dear students, to this other lesson after treating a very important concept in database, which is normalization. Today, we are going to look at a particular aspect that normalization is solving, which is nothing other than data anomalies. Database anomalies are inconveniences or problems that arise in relational databases when data is inserted, updated, or deleted. These issues typically occur in poorly planned or unnormalized databases. Anomalies can result in data integrity issues, making it difficult to maintain accurate and consistent information. So in general, that is what we call database anomalies. The main causes of database anomalies are redundancy, unnecessary dependency. Remember that the main issue, one of the main objective of database normalization is to make sure that dependency makes sense. That is why one of the causes of database anomaly is what? Unnecessary dependency, such as partial and transitive dependency. Poor schema design. Three types of anomalies are insertion, deletion, and update, which is also known as modification. The first one, which is insertion anomaly. An insertion anomaly occurs when one cannot insert a new record into the database without providing values for unrelated attributes, or when inserting data leads to incomplete or null values, violating data integrity. An insertion anomaly occurs when certain fields cannot be inserted into the database without the presence of other fields. E.g., a library database cannot store the details of a new student until that student has borrowed a book. As example, this is what we have. Consider this table. It shows our key fields here are student ID and book ID. So if I want to insert a new student, automatically he has a student ID, he has his name. But if it's that I want to introduce the student in the database of the school, and he has not yet borrowed a book, or he does not have an intention of doing so, it means that the attribute book ID, category, borrowed it and returned it are going to be null. Whereas we know that one property of key fields that they cannot be null, and this will result to an error since book ID will be null, and this is what we call an insertion anomaly, because while trying to insert a particular data, we are having some attributes which are null, and if such attribute, among those attributes there is a key field, then it's going to result to a data integrity error. And most specifically we call that the domain integrity. I think something like that. The next type of anomaly is the deletion anomaly. A deletion anomaly occurs when certain attributes are lost because of the deletion of other fields. That is, when I'm trying to delete a particular record, it deletes other information that are not required to be deleted. A record of data can legitimately be deleted from the database, which is something normal. For example, you have a particular student in your database, and later on the student is not more present in the school, and you have to delete that particular record that is from that particular class. For example, if you want to print the class list, that's what we say legitimately deleted. And the deletion can result in the deletion of the only instance of other required data. So while you are trying to delete a particular data, it deletes also some instances of important data that did not require to be deleted. As example, deleting the details of a student from the table above will result to loss of a particular book from the entire database. For example, if we delete this first row, so if I delete the student Chobo Maeva, what am I going to have? If I delete this row, you see that it's going to delete the book with ID BK01 with this category and this other information. But what I'm trying to delete is just this particular student who may not be present in our school again. And this deletion will result to what? The deletion of the book with ID BK01. And this leads to what we call a deletion anomaly, because while I'm trying to delete this, it also deletes an important information which does not need to be deleted. And that is why we said here, like in insertion anomaly, when we are trying to insert a new record into the database without providing values for unrelated attributes, it's the same thing here. You see that I am deleting information about attributes which are not actually related to the actual data I want to delete, because book ID category are not directly related to the student ID. Now, the last type of anomaly which we are to see is the update, also known as the modification anomaly. An update anomaly occurs when one or more instances of duplicated data is updated but not all, or when an update leads to inconsistencies because redundant data is not updated uniformly. That is, for example, you have many instances of a particular student ID in a particular table. Many instances doesn't mean it is redundant. No, it means that it is, for example, in a particular table where student ID is part of the composite key. In that case, you can have several instances of a particular student ID. And now, if the student ID of a particular student is erroneous and you want to change it, updating part of it but not all can lead to an anomaly, or which is the or is even the same thing, because if you just update part of it, you are going to have some problems, because at the end you might run your query. If you run your query with the new student ID, you are not going to have the output with all the records, and if you run with the old ID, you are going to have the same thing, and that will call an update anomaly. Incorrect data may have to be changed, which is something normal because we all make errors when entering data. So when they are changed, it could involve many records having to be changed, leading to the possibility of some changes being made incorrectly. Now, all these anomalies are what we encounter when we have poorly planned databases, unnormalized databases, and databases containing useless dependencies such as partial and transitive dependency. I hope you enjoyed the video. We are coming to the end because this particular video was only for database anomalies. In our next video, we are going to look at case study number 2, because the first case study that we saw was how to obtain AI diagram from description and mapping it to the relational equivalent. In the case study number 2, we are still going to have exercises from the case study number 1 we had, and also more on normalization and anomalies. And when we talk of anomalies, it will be at the level of using a particular table to point at a particular anomaly that we can have, normalizing the table, and use the normalized table to explain how the anomalies we could have in the unnormalized table have been eliminated. I hope you'll be present in the next video. Do not forget to like, to subscribe, and to share for our community to grow. And see you in the next video. Thank you very much.